So last week we spent some time talking about the general Hough transform. And the power of the general Hough transform is to be able to detect any object of any shape inside an image. So I thought that was pretty powerful, but it turns out that there's something that is even better. What they would do is in the MPEG-7 shape descriptor. One of the shape descriptors is the curvature scale space. Surprisingly, there's no Wikipedia article on this, and there's very few YouTube videos on this. So I thought this is a good topic that we discuss, as well as this is something that was mentioned in class. So the curvature scale space is essentially looking at the curvature, the inflection points of the curvature of the shape. So what that means is if you have a shape, when that curvature inflects into another direction, you register that inflection point. And we remember the inflection points of the shape. And based on that inflection points of the shape, we go find this image in the image space that we're searching for. So it's another way to find the shape we're looking for relative to the general Hough transform. The advantage of this is that it really allows for variations in shape. So it's not very really hard. I guess general Hough transform also allows you to do that by you can have less tables. So instead of having an R table that is very precise, you could have an R table that is less precise. Then you can get the peaks as well. But in the curvature scale space, if you stretch out the image, or if you have an image that is similar, that is something that the general Hough transform cannot do, but the curvature scale space can do. And we're going to look at how the curvature scale space can do that. But a good scale, a good shape descriptor should be scale invariant, rotation invariant, and translation invariant. So it should be able to recognize the shape regardless of the angle, the rotation, and the size of the shape. So that would be a good shape invariant. So in the curvature scale space, what we would do is we would take a picture and then we would translate that picture into the curvature scale space, which looks like this. And in this curvature scale space, if the image have a lot of noise in them, then it's going to have a lot of little bumps. And these little bumps creates a lot of little inflection points. And on the top of the curve space, so this curvature scale space on the x-axis, have the have what we call T, which is the curvature inflection points, where the inflection point is. And on the y-axis have the sigma, which is if we were to convolute this with a Gaussian filter, how much inflection points do we maintain? So as you convolute a shape with a Gaussian filter with larger and larger sigma, it's going to lose more and more of its details. And sometimes that's good because a lot of the details are noise. Other times it's bad because you aren't actually finding the image that you're looking for because those are noises. So in that sense, as you convolute a shape with a Gaussian filter, you can smooth out the shape. And once you smooth out the shape, you would get the inflection points that you're looking for. Now, because the shape is convoluted with a Gaussian filter, the inflection points where the inflection points happens may change, and you're going to lose inflection points as you have a bigger sigma, because now there are less places where a curve goes from this direction into this direction, because this could be a noise. So from that sense, you recognize all the inflection points, and you take these inflection points, you go into the image, and you search for it. And this will let you find the image you're looking for. If the shape is rotated, the same curvatures will still be there, but they'll just be at different points of the curvature scale space. So the curve will still be inside the curvature scale space, but it's going to be at a different t level. And that's what I meant. So with scale rotation. Now with size, like translation invariant, because the curve is the same, the curvature is the same, the inflection points will be preserved. So in that sense, it's also very robust. And if you pick a sigma that's large enough, it's also very robust to noise. So this is another way to identify shapes in the object. And I think that's a brief general overview introduction of the curvature scale space.